Hello, pre-algebra, and welcome to our lesson 8.2 discussion and examples. In this lesson, we will be talking about solving two-step solutions, which is just building on what we did in lesson 8.1, in which we learned how to use operations to undo an operation, right? So we use division to undo multiplication, we use subtraction to undo addition, etc. So let's take a look at this. So a two-step equation contains two operations, right? So that means that at least on one side of the equation, there's going to be two different operations. So that may mean that we have multiplication and division. Maybe we have division and subtraction. Maybe we have multiplication and subtraction. It doesn't really matter. It just means that we have more than one operation on one side of the equation. And although we're talking about two-step equations here, and you're going to see that the example here just has two, really this applies to any equation in which there are multiple operations on one or even both sides of the equation. So to solve a two-step equation, we use inverse operations like we talked about in 8.1, our previous lesson, to undo each operation in reverse, or to undo each operation. And here's the key thing though about this. We do this in reverse order of operations, right? So remember, our order of operations is we always do our multiplication and division first, and then we do our addition, and then we do our subtraction. And that's the basic of it. There are, of course, some other operations like square root and things like that, but we aren't going to encounter those right now. So if we just stick to those basic, right, we do our multiplication and division first, followed by subtraction or addition and then subtraction. Well, when we are undoing these equations to solve for the variable like x, we do it in reverse order of operations. So that means we're actually going to start. Let me write those back here again. That means we're going to actually start, usually we start up here and we work this way. That's our normal order of operations. But when we're solving equations and we're trying to solve for a variable like x, we're going to start here with subtraction and work our way up to multiplication. And that's what we mean by reverse. So if we look at our problem here, 6x plus 1 equals 25, right? We're going to note that we have two operations on this side, on the left side of the equation. We have multiplication, 6 times x, and we have addition, plus 1. So we're going to do the opposite of the operation, and we're going to start here with our subtraction, and then addition, division, multiplication. So this tells us that we deal with addition, subtraction first. So this is a addition. So we're going to deal with that first. We're going to deal with that plus 1 first. And how do we deal with it? Well, we do the opposite. So the opposite of adding 1 is subtracting 1. So if we have 6x plus 1, we're also then now going to subtract, oops, we don't need a parenthesis there. We're going to subtract 1. And what we do to one side of the equation, remember, we must always do to the other side. So we are also going to subtract 1 from this side. That's going to give us a new equation. That's going to give us 6x equals 24. Okay, because we subtracted on the left side of the equation, we subtracted 1 from 1, and on the right, we subtracted 1 from 25. Now we have multiplication, 6x. That's 6 times x. So in this case, we need to divide. So that means we're going to have 6, I'm trying to stay consistent here, 6x divided by 6 equals 24 divided by 6. And in this situation, of course, the 6x divided by 6, those 6's are going to cancel each other out. That's going to be 1, leaving us with x. And 24 divided by 6 is going to be 4. So that means that x equals 4. This is what we call our solution. Now up here, so we've done this part. Up here it tells us that we need to check our solution. And so we do that by going back to our original formula. 6x plus 1 equals 25. And we insert the value of x into our equation. So now we're going to have 6 times 4 plus 1 equals 25. 6 times 4 is 24, plus 1 equals 25. Ah, look at that. 24 plus 1 is 25 equals 25. And so we have checked our solution. All right, let's try one more. Two more, sorry. 2x plus x minus 27. Notice there's actually 3 operations here, but like I said, it's not going to be that big of a deal. So let's set that up here. So let's ask ourselves a couple questions here. When we have something like this, we may need to, like we learned in chapter 7, we may need to actually do some combination here of our variables. So let's go ahead and do that first. Let's go ahead and say, let's add those terms because those are like terms, right? So we're going to add our like terms first. We're going to go ahead and do that operation over here. And that gives us actually a 2-step equation. So like terms, 2x plus x, that's 3x minus 27 equals 3. And now we have a 2-step equation, and we're going to do just like what we did before. So we're going to have 3x minus 27. We're dealing with our subtraction first. The opposite of subtraction is addition. So we're going to add 27 there. Oops, the equal sign this color. And we have 3, and we're going to be adding 27 to that side. So our new equation is now going to be 3x equals, because minus 27 plus 27, that is 0, so that gets rid of those, right? So that cancels all that out. And over here, 3 plus 27 is 30. So now we have 3x equals 30. Well, since this is now 3x is a multiplication problem, we're going to divide by 3, doing the opposite, right? This is multiplying x by 3, so we're going to divide that by 3. And what we do to one side, we have to do to the other. Those 3's cancel out, which means that we now have x equals, and 30 divided by 3 is 10. That is our solution. And we can plug that in and check it real quick. I'm just going to do it up here, kind of above the problem, save some space here. So 2 times 10 plus 10 minus 27 equals 3. So 2 times 10 is 20 plus 10 minus 27 equals 3. 20 plus 10, that's 30 minus 27 equals 3. 30 minus 27, yep, 3 equals 3. So we have checked it. Okay. All right, let's try this one here. Here we have 1 over 3 times p plus 6 minus 2 over 3 times p equals 0. So again, we're going to go ahead and look for like terms and do the operations that are with those like terms. So this is 1 3p minus 2 3p plus 6 equals 0. Notice I just rewrote the order, which we can do that, right? We can rewrite the order when it's addition or subtraction. So then we just got to look at this. So 1/3 minus 2/3. Well, remember when the denominators are the same, right? we can just simply do the operation at the top of the numerator. So this is 1 minus 2, which is negative 1 over 3p plus 6 equals 0. Now we can start undoing, so to speak, this equation. So we're going to start with that plus 6, because now we have a two-step equation. So negative 1, 3p plus 6 minus 6, that's the undoing of the 6, equals 0 minus 6, which means that we now have a new equation of 1 over 3p equals minus 6, or negative 6. Now remember, this is a the fraction 1 over 3 is really just a division problem, so we are going to multiply. We're going to multiply that by 3. I'm just going to write it here. So let's multiply that by 3. And 3 over here. Okay. And we actually have to do the same thing here. We got to remember that to undo it, we are going to need to keep that negative sign on both of these. So this is undoing it by negative 3. So negative 3 times 1 over 3 is 3 over 3p equals negative 6 times negative 3 is positive 18. 3 over 3 cancels out. P equals 18. And I changed colors. I just realized that, but that's our solution. Right, and then we plug it back in to check. And if we do that, we would do 1/3 of 18. So 18 divided by 3. So 3 times 18 plus 6 minus 2/3 times 18 equals 0. I ran out of space there. And so if we were to get our calculators, we were to do this by hand, we would find that that indeed is true. 6 times 3 is 18, so 1/3 of 18 is 6, plus 6 minus 2/3 of 18 happens to be 12, and that equals 0. So we do all that together, right? 6 plus 6 is 12, minus 12 equals 0. And 12 minus 12 is 0 equals 0, which means that we have checked our answer. All right, moving on. Solve real-world problems. So we can write and solve two-step equations to solve many real-world problems. So let's take a look at those. Dion wants to go on a camping trip with his hiking club. The trip cost $185.75. He paid a deposit of $45.75 and will save an additional $17.50 per week to pay for the trip. Now notice in this equation they have given us, these actually are in this word problem, they've given us the equation right here. Eventually you're going to be asked to write that out yourself, to figure out how to set that up yourself from the word problem. So as you look at this, just keep in mind, right, let's go back and see how they did that. Right, the trip cost, the total cost is here, so that's what this equation is going to equal. So that matches this. Use some different colors, right? He starts with this, so that's a starting point. And then he has this amount per week. And notice that that looks like $17.50 per week, looks like $17.50 times W. That per, right, that means multiply. Okay, so that's how they set it up. And so right now, all we need to do is we need to solve it and check our answer. So 45.75 plus 17.50 per week equals a total of 185.75. Well, Here we have a positive, right? Here we have a positive, so this is what we actually need to get rid of, because we are going to keep this by itself so that we can isolate that W later. In order of operations, we have to do with this one. And remember, we can write these in any order. So we could have written this 1750W plus 45.75. That's a positive number. To get rid of it, we need to subtract. So we are going to write this equation as 45.75 minus 45.75 plus 1750 W equals 185.75. And what we do to one side, we have to do to the other, minus 45.75. Okay, so now we can just do that math, right? And again, just whip out your calculator if you're not sure about doing it or you don't want to take the time to do it by hand. So that means that we now have a new equation. 185.75 minus 45.75 is 140. And now, because these got canceled, right? That canceled that out. What we have left on this side is 1750 W. This is now a multiplication, so we're going to have to divide this. So we're just going to divide this by 1750, which means we have to divide this side by 1750. That's going to cancel, leaving us with W equals 140 divided by 17.5 is 8. So that means it's going to take Dion 8 weeks to come up with the money he needs for his camping trip. And then, of course, so that's our solution. Now we need to check our answer. 45.75 plus 1750 times 8 equals 185.75. Just try and keep that separate there. Right, so again, just type into our calculator, 17.5 times 8 equals 140. Ooh, look at that. We've seen that number before. So our new formula, I ran out of room there, is 45.75 plus 140 equals 185.75, and we add those together, and indeed we have 185.75 equals 185.75. So there's our check. All right, one more. Again, a caterer is preparing a dinner for a party. She charges a flat fee of $16 plus $8.25 per person. Solve 16 plus 8.25. P equals 131.50 to find the number of people at a dinner that costs $131.50. Solve and check your solution. Again, right, if we're reading the first part, we are told that the total dinner costs $131. So that's this number here. That's the equal, right? That's what everything is going to equal. We're also told that there's a flat fee. So whether there's one person or 700 people, it's $16. And we add that $16 to another number with a variable. $8.25 per person. And again, that per person is that multiplication clue. And so there that is. And that's how we figure that out. But again, this problem gave it to us. So let's just begin solving for P. In other words, how many people are going to attend a dinner if the total cost is $131.50. Again, Don't let the fact that the 16 is in front fool you. That's still an addition problem because it's a positive number. If it was a negative number, we would just do the opposite. If this was written like this, negative 16, we would just then add 16, but it's not, so we're not going to do that. This is a positive number, so we're going to do the opposite operation. So we're going to have 16 minus 16 plus 8.25p equals 131.50 minus 16. That takes care of that. We do our operation over here, our subtraction. So 131.50 minus 16 is 115.50, and this is 8.25p. Again, this is a multiplication problem, and so we're going to be doing the opposite operation, and the opposite of multiplication is division. So we're going to divide this side by 8.25. We're going to divide this side by 8.25. That's going to cancel that out, leaving us with p equals 14. So that means there are 14 people that are going to attend this dinner. We can check that. So this is our solution. And then we can check that. 16 plus 8.25 times 14 equals 131.50. Right, 14 times 8.25. 16 is 115.50, so 16 plus 115.50 cents equals 131.50. 16 plus 115 is indeed 131.50 cents, which is what our equation tells us that should be. So we have now checked our answer. All right, the last thing that we need to know about this two-step equation is that we can use a two-step equation to solve perimeter problems. Okay, so if we have a problem like this, we've been given a shape, in this case a triangle, and we are told that the perimeter is 22 inches. And remember, the perimeter is just all side lengths, I should say, added together. So that means if we add x plus 3 plus 9, we're going to get 22 inches. And that's what the problem here has told us, but we could do that on our own because we know what a perimeter is. So we have x here. Let me erase that and color coordinate this a little bit. So we have x, and then we're going to add x plus 3. Let me do this in black real quick. Plus, and that was this one here, plus 9. And that equals 22 inches. So again, we're going to first combine like terms, and then we're going to start to undo the equation to solve for, in this case, x. So let's look for those like terms. X and x are like terms. Whole numbers are like terms. So we can do those operations. In this case, that happens to be addition. So x plus x is 2x, and we're going to keep that plus sign. And 9 plus 3 is 12, equals 22. Now we have a two-step equation like we started with, like we saw at the very beginning. So what are we going to do here? We're going to do some subtraction. So this is going to be 2x plus 12 minus 12 equals 22 minus 12. That's going to cancel those out, so that's 0. And over here, 22 minus 12 is 10, and that we have a 2x remaining over here. Now we have to get rid of that 2, so that's 2 times x. The opposite of multiplication is division, so we're going to divide both sides by 2, which leaves us with x equals 5. And that is our solution. Now, we could solve that. We could do it a couple different ways. We could take that x and we could say, okay, so this is 5 plus 9 going this way. 5 plus 3. So 5 plus 3 equals 8. Right, so now we have 8 plus 9 plus 5. Let's try it that way. 8, that's 17 plus 5 is 22. Hey, look at that. That's one way to check it, right? The more traditional way, right, the proper way, algebraic way, is to take that 5 and plug it in, which is actually what we did over here. Notice, right? That x became a 5, that x became a 5. And so that's what we did. I just need to write it instead like this. 5 plus 3 plus 9 equals 22. And then it's the same as that equation. And we already figured out that that equals 22. All right, that ends this lesson. That was a little longer than usual, but hopefully that gives you some samples and some instruction on how to solve these. Have a great day.